Welcome to our deep dive into the wonderful world of elements.
Elements?
Yeah, we've got like a really fascinating mix of sources for this one.
Oh, yeah.
YouTube documentaries, science explainers, even peeked into the
Wow.
life of Marie Curie.
Nice. So,
Yes.
yeah, get ready to uncover some hidden stories.
Yeah,
And maybe even see these building blocks
yeah,
a whole new light.
it's going to be fun. So,
Absolutely. And what's really excited is that we'll be looking at elements from all angles.
okay.
Okay? Their history, the science behind them,
hmm
even how they impact things like economics and geopolitics.
Okay, let's start with gold. I mean, who isn't fascinated by gold?
Right.
One of our sources takes us right into the Cortez mine in Nevada,
Uh-huh.
where they're mining gold like in the 21st century.
Yeah, it's incredible to think that they're pulling microscopic gold out of tons of rock.
Yeah?
They said it's like finding an ounce of gold in a whole ton of rock.
Wow.
Talk about a needle in a haystack.
It's mind-boggling. And then they showed this massive, like 60-pound gold bar.
Right. Being poured $1.5 million just sitting there.
Wow.
Makes me wonder how something so rare became so important to us, right?
Well, gold has some really unique properties that make it stand out.
Okay. It's incredibly resistant to rust and tarnished, unlike a lot of other metals.
Mhm.
And it's incredibly soft and valuable, meaning you can shape it easily.
Oh, okay.
That's why it's been used for everything from jewelry to electronics for centuries.
Okay, they kept calling it a noble metal.
Oh, yeah.
What does that even mean, like in the world of chemistry?
Noble in chemistry means unreactive.
Okay.
Gold, unlike a lot of elements, doesn't want to react with others.
Huh.
And it all comes down to those tiny electrons
Uh-huh.
whizzing around each atom. Gold has what we call a full outer shell of electrons.
Okay.
Imagine it like a puzzle where all the pieces fit perfectly.
Right.
A full shell makes the atom stable and happy, so it doesn't need to react with other elements to fill any gaps.
So it's like gold is already living its best atomic life.
Ex-
Let's move from a metal that's pretty rare to one that's all over the place.
okay.
Copper.
Copper.
One of our sources took us to the New York Mercantile Exchange,
Uh-huh.
where they trade millions of tons of copper every year.
Copper is such a global commodity, and its price is actually used as an economic indicator.
Oh, really?
They called it Dr. Copper
Dr. Copper.
because it can tell us how the global economy is doing.
That's pretty cool, but why is copper so important in the first place? I know it's in like electronics and stuff, but...
Yeah, well, think about how we use electricity.
Okay.
Copper is an excellent conductor of electricity,
Uh-huh.
meaning electrons can flow through it very easily.
Yeah.
That's why it's used for wiring and everything, from our homes to our smartphones.
Okay, that makes sense. So copper is a great conductor on its own, but our sources also talked about mixing it with other metals
Yes.
to make something even better.
alloys.
Bronze. I'm picturing those old bronze bells they used to make.
Yes. Our sources took us to the Verdun Company, where they still cast bronze bells.
Wow.
Using techniques that are centuries old.
Cool.
And the sound of a bronze bell is truly unique.
Yeah.
It's all thanks to how the copper and tin atoms
Uh-huh.
interact at a microscopic level.
So how does adding tin to copper change the sound?
Think of it this way. Copper is relatively soft and flexible.
Okay.
But when you add tin,
Yeah.
those tin atoms fit themselves into the spaces between the copper atoms,
Huh.
making the whole structure more rigid.
Okay.
That rigidity is what gives bronze its long, resonant ring.
Oh.
It's why a bronze bell can create those beautiful, lingering tones.
They even showed us the Liberty Bell, which, as you probably know, has a pretty famous crack.
Right.
I guess what they think the crack might have happened because the bronze they used had too much tin in it,
Too much tin.
making it brittle over time.
Yeah, it's a reminder that even the seemingly simple act of mixing metals
Yeah.
has a complex scientific backstory,
Right.
and those tiny atoms are really calling the shots.
Speaking of atoms, our sources took us on a wild ride into the microscopic world
Literally.
with an electron microscope at Cornell University.
Amazing.
We literally got to see individual atoms.
It's mind-blowing, isn't it?
Yeah.
It's proof that atoms aren't just some abstract idea.
Right.
They're real, tangible things.
Yeah.
And seeing them up close helps us understand how elements behave
Yeah.
and why they have the properties they do.
It zoomed in on a piece of bronze from a bell, and it was like going from a map of the U.S.
Wow.
to a single car, and then boom, there are the atoms.
There they are.
I never thought I'd get to see something like that.
It's amazing to think that Dmitry Mendeleev, the creator of the periodic table,
Mm-hmm.
organized all these elements based on their properties before anyone even knew about atoms.
Yeah.
He was basically predicting the existence of things he couldn't even see.
Now, that's a visionary. But let's move from the structure of atoms to how they react with each other.
Okay.
One of our sources featured Theo Gray, who's a bit of a mad scientist.
It is.
When it comes to
A
chemistry,
little bit.
he showed us just how reactive some elements can be.
Theo definitely has a knack for making science exciting.
Yeah.
And his demonstrations with alkali metals like sodium
Yes.
really drive home on the point about how eager some elements are to react.
They did this whole experiment at night where they dropped sodium in water,
Uh-huh.
and let's just say it involved a big explosion and a lot of fire.
It was a dramatic illustration of what happens when an alkali metal,
Yeah.
which has an extra electron it wants to get rid of,
Uh-huh.
encounters water.
Yeah.
The sodium gives up its electron,
Mm-hmm.
and that triggers a chain reaction
Right.
that releases a lot of energy, hence the explosion.
Yeah, I'm kind of glad we were watching that from a distance.
Me too.
But then they showed the opposite,
Oh, yeah.
sodium reacting with chlorine gas.
Okay.
And instead of an explosion, we get table salt.
Right, and that's because sodium and chlorine are a perfect match, atomically speaking.
Wow.
Sodium has that extra electron it wants to give away,
Uh-huh.
and chlorine has a space in its outer shell,
Yeah.
just waiting for an electron to fill it.
Okay.
So they combine, neutralize each other,
Wow.
and form sodium chloride, the salt we use every day.
So sometimes opposites attract, at least in the world of elements.
And
speaking of reactivity, we can't forget about oxygen.
the element we literally breathe every second.
Yeah, our sources dove into how oxygen is involved in everything from life to explosions.
It's true. Oxygen plays a vital role in so many processes.
Yeah.
It's essential for respiration, which is how our bodies get energy.
Right.
But it's also a key ingredient in combustion,
Okay.
which is basically a rapid reaction between a substance and an oxidant, usually oxygen, that produces heat and light.
We got to see this firsthand at the Energetic Materials Research and Testing Center.
Oh, wow.
They blew up a car using 300 pounds of ANFO, which is basically a fertilizer bomb.
ANFO stands for ammonium nitrate and fuel oil.
Okay.
And it's a powerful explosive because the ammonium nitrate provides a lot of oxygen to fuel the reaction.
Oh, wow.
It's a stark reminder of how readily available materials can be
Yes.
turned into dangerous weapons.
And then they detonated a pound of C4, which just vanished in an instant.
Wow.
It's incredible how such a small amount can unleash so much energy.
C4 is a military-grade explosive,
Mm-hmm.
and its power comes from the rapid combustion of its ingredients, again fueled by oxygen.
Okay.
The key is how densely packed the C4 is. The
Uh-huh.
closer the molecules are, the faster and more powerful the reaction.
It's fascinating to think that the same process combustion that powers explosions also powers the controlled burning of fuel in our bodies.
Exactly.
All thanks to oxygen.
It highlights the interconnectedness of the physical world.
Yeah.
The same fundamental principles apply across a vast range of scales,
Right.
from the microscopic to the macroscopic.
Now let's shift gears from explosions to something a little more peaceful.
Okay.
The building blocks of life itself. Remember CH-NOPs?
CH-NOPs, carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. Those 6 elements are the essential ingredients for all life as we know it.
And to show us just how much of each element is in our bodies,
Uh-huh.
one of our sources took us on a rather unusual shopping trip
They did?
Yeah.
Where'd they go?
to a hardware store.
A hardware store.
Yeah, with Christine Thomas to gather the elements that make up a human body.
Interesting.
Yeah, we're talking charcoal for carbon,
Okay.
water for hydrogen and oxygen,
All right.
fertilizer for nitrogen, matches for phosphorus,
Uh-huh.
and even a tire for sulfur.
Wow.
It was a really creative way to visualize how these everyday items
Yeah,
connect to the very essence of who we are.
it's true.
They even calculated how much of each element is in a 185-pound person.
Okay.
33 pounds of carbon,
Wow.
120 pounds of oxygen,
Interesting.
and a tiny amount of sulfur, about as much as you'd find in a single tire.
Huh.
It really makes you appreciate the complexity of the human body.
And even though those 6 elements make up the bulk of us,
Yeah.
there are also trace elements that are vital for our health,
Okay.
especially for athletes.
Okay.
Our sources took us behind the scenes at an athletic training facility
Uh-huh.
where they were conducting tests to analyze the role of elements like zinc, potassium, magnesium, and sodium
Okay.
in athletic performance.
We saw her measuring bone density,
Uh-huh.
analyzing sweat,
Okay.
and monitoring athletes on treadmills.
Wow.
It was pretty cool to see how these tiny amounts of elements
Right.
can have such a big impact on how our bodies function.
It really emphasizes that we're more than just the sum of our parts.
Yeah.
Our bodies are incredibly complex systems
Yeah.
that rely on a delicate balance of elements working together
Yeah.
to keep us going.
Speaking of going, how about we go way back in time,
Okay.
billions of years, to the very origins of elements?
The Big Bang.
Our sources took us on a journey that began with the Big Bang.
That's a long journey.
Yeah, the event that kickstarted our universe.
The Big Bang is mind-blowing to think about.
Yeah.
All the matter and energy in the universe
Mm.
compress into an infinitesimally small point.
Right.
And then, boom, everything expands outward.
Wow.
And the first element, hydrogen, is born. Simple, abundant hydrogen, the foundation for everything that comes after.
And from there, our sources zoomed in on the heart of a star.
Oh, wow.
Where things get really heated.
Literally.
We witnessed the process of nuclear fusion, where hydrogen atoms are forced together under immense pressure to form helium.
Fusion is the engine that powers stars,
Yeah.
releasing tremendous amounts of energy in the process.
Right.
Is what makes stars shine.
Right.
And it's also how heavier elements are created.
It's amazing to think that the same process happening in distant stars
is
what created the elements that make up our bodies and everything around us.
Exactly. It highlights the deep connection between us and the cosmos. We are quite literally stardust.
But the story doesn't end there. Our sources took us on a journey to witness the spectacular death of a star in a supernova explosion.
A supernova.
It's in these incredibly powerful events that even heavier elements beyond helium are forged and scattered throughout the universe.
Supernovae are the ultimate cosmic recycling plants.
Wow.
They take the building blocks created in stars and spread them out, seeding the universe with the raw materials for new stars' planets.
Wow.
And even life.
It's like a cosmic dance of creation and destruction.
It is.
And it's all thanks to the amazing properties of elements.
Absolutely. And from the vastness of space, let's zoom in on our own planet in its early days.
Okay.
A world very different from the one we know today.
Right.
A world without oxygen.
It's hard to imagine a world without oxygen.
I know.
The element we depend on for every breath.
Right.
But early Earth was a very different place. Our sources took us to the otherworldly hot springs of Yellowstone National Park.
Oh, cool.
Where we met the tiny heroes that changed everything.
Who are they?
Cyanobacteria, also known as blue-green algae.
Cyanobacteria are fascinating organisms. They figured out how to use sunlight and water to create energy, releasing oxygen as a byproduct.
Okay.
It was a game changer for our planet.
It's mind-blowing to think that these tiny microscopic creatures
I know, right?
transformed Earth's atmosphere and paved the way for oxygen-breathing life.
Yeah, we literally owe our existence to them.
It's a reminder of the profound impact that even the smallest organisms can have on our planet.
They are the unsung heroes of our evolutionary history.
From the smallest organisms to one of the most abundant elements on Earth.
What's that?
Silicon. Our sources explored silicon's ancient use in glassmaking and how it's now at the heart of the digital age.
Silicon is incredibly versatile.
Yeah.
From the ancient art of glassmaking to the cutting edge of modern technology, it has shaped human civilization in profound ways.
It's amazing how we've learned to manipulate silicon at the atomic level to create things like Gorilla Glass.
Right.
Which is so strong it can survive being shot with a hail gun.
Wow.
It's like something out of a sci-fi movie.
Gorilla Glass is a fantastic example of how understanding the properties of elements at the atomic level allows us to create new materials with incredible properties.
And of course, we can't forget silicon's role as a semiconductor.
Right.
The foundation of all our electronics.
It's incredible to think that the same element found in sand is what powers our smartphones and computers.
Silicon's ability to act as both a conductor and an insulator, depending on how it's manipulated, is what makes it so valuable in electronics.
Right. It's the basis for the transistors that control the flow of electricity in our devices.
Speaking of valuable, our sources took us on a journey into the world of rare earth elements.
Oh, yeah.
Which are essential for modern technology.
Yes.
But also surrounded by a lot of geopolitical intrigue.
Rare earth elements are a group of 17 elements with unique magnetic and luminescent properties that make them critical for a wide range of technologies. From smartphones and computers to electric vehicles and wind turbines.
Our sources focused on neodymium, the key ingredient in the world's strongest magnets.
Oh, wow.
We visited Molycorp's rare earth mine in California, the only one in the U.S.
Really?
And learned that rare earths aren't actually that rare.
Interesting.
They're just really hard to separate from each other.
That's the challenge with rare earth elements.
Yeah.
They have very similar chemical properties. Which makes it difficult and expensive to extract and purify individual elements.
We got to see how scientists at the Ames Lab in Iowa are using sophisticated techniques to isolate individual rare earths.
Like a high-stakes game of atomic Jenga?
It is. But here's a twist that I definitely didn't see coming.
Oh.
Rare earths can also be used as shark repellents.
Really?
Apparently, it was a serendipitous discovery. That could have a huge impact on both fishing and conservation.
It's an unexpected application of rare earths.
Yeah.
And it highlights how scientific exploration can lead to surprising discoveries
Right.
with real-world implications.
They even showed a live demonstration of a shark reacting to a rare earth metal as if it were kryptonite.
Wow, the science behind it is fascinating.
Yeah.
The rare earth metal creates a tiny electrical current in seawater that sharks can sense, and they seem to find it very unpleasant.
It's amazing how a simple element can have such a wide range of uses, from powering our smartphones to potentially keeping sharks away. It really makes you wonder what other hidden secrets the elements hold.
The periodic table is a treasure trove of possibilities.
Yeah.
It's a testament to the ingenuity and creativity of scientists who are constantly exploring new ways to harness the power of elements, to solve problems, and advance our understanding of the world.
And that's just the first part of our deep dive into the world of elements. Stay tuned for part 2, where we'll explore the amazing world of isotopes, unlock the secrets of the past, and delve into the power of uranium and the quest for new elements.
We've only just begun to scratch the surface of the wonders that the periodic table has to offer. Get ready for an even deeper exploration of the building blocks of our universe and the profound impact they have on our lives.
Welcome back to our deep dive into the elements, ready to keep exploring.
Absolutely. Let's dive into a topic that might sound a bit obscure, but is actually incredibly fascinating: isotopes.
Okay, isotopes. Break it down for me. What are they all about?
Think of isotopes like different versions of the same element. They're like siblings with the same family name but slightly different personalities.
All right.
They have the same number of protons, which determines their atomic number and what element they are. But they differ in the number of neutrons, those neutral particles hanging out in the atom's nucleus.
So same element, different atomic weight. Does that actually change how the element behaves?
Sometimes, yes. And to illustrate this, we're going to focus on a very special isotope.
Okay.
Carbon-14.
Carbon-14.
It's radioactive, and that radioactivity acts like a built-in clock, allowing us to determine the age of ancient objects, a technique known as carbon dating.
Carbon dating, I've heard about that, but I don't really understand how it works.
It's pretty ingenious, actually. Living things constantly absorb carbon from the environment, including a small amount of carbon-14. When an organism dies, it stops taking in carbon.
Okay.
And the carbon-14 it already has begins to decay at a very predictable rate.
So by measuring how much carbon-14 is left in something like an ancient bone or a piece of wood, scientists can figure out how long ago it died.
Exactly. It's like looking back in time.
Wow.
And to see carbon dating in action, our sources took us to Motto Lake in California, where scientists are studying ancient trees that died during a drought.
Oh, wow.
It's a unique environment because the lake's high salt content has preserved these trees for thousands of years.
It's like a window into the past. So they're using carbon-14 dating to figure out when those droughts occurred.
Yes, and that information helps us understand long-term climate patterns.
Oh, okay.
By studying past climates, we can get a better picture of how Earth's climate has changed over time, which can help us predict future climate changes.
So carbon-14 is like a time traveler, helping us connect the present to the past.
I like that.
But isotopes aren't just for looking back in time. They also play a crucial role in the present, especially when it comes to energy.
Energy.
And our sources spent a lot of time talking about one element in particular, uranium.
Uranium is a fascinating and complex element. It's incredibly powerful, capable of releasing enormous amounts of energy through nuclear fission, which is the process of splitting an atom's nucleus. This power can be harnessed for good, as in nuclear power plants, or for destruction, as in nuclear weapons.
It's kind of mind-blowing that we can split an atom and release so much energy. To be honest, it's a bit intimidating.
It's definitely a powerful force, and one that needs to be handled with great care and responsibility.
For sure.
Our sources took us to a lab where they demonstrated a chain reaction using a model made of mousetraps and ping pong balls.
Mousetraps and ping pong balls.
It might sound silly, but it's actually a really clever way to visualize how nuclear fission works.
I'm intrigued. How does that even work?
Imagine setting up a bunch of mousetraps, each loaded with a ping pong ball. Then you toss one ping pong ball into the mix, triggering one mousetrap to snap, which launches its ping pong ball, which triggers another mousetrap, and so on. The reaction cascades, quickly releasing a lot of energy.
I'm starting to get it. Each ping pong ball represents a neutron.
Yes.
And when it hits us trap, it triggers a fission event, releasing more neutrons that trigger more fission events.
Exactly. And just like in the mousetrap model, a nuclear chain reaction can release a tremendous amount of energy very quickly.
Wow.
That's the principle behind both nuclear reactors, where the reaction is controlled to generate electricity, and nuclear weapons where the reaction is uncontrolled,
Right.
leading to a massive explosion.
It's amazing and terrifying at the same time.
It is a powerful force.
Our sources all talked about the history of nuclear weapons, including Little Boy,
Right.
the uranium-based bomb dropped on Hiroshima and Fat Man, the plutonium-based bomb dropped on Nagasaki.
Yeah, it's a dark chapter in human history.
Yeah, and it's hard to even fathom the destructive power of these weapons.
It's a stark reminder of the importance of understanding the science behind these technologies
Right.
and working towards peace and disarmament. But uranium's story isn't all doom and gloom.
Okay.
It also has the potential to provide a significant portion of the world's energy needs through nuclear power plants, which produce electricity without emitting greenhouse gases.
So uranium is a bit of a double-edged sword.
It is.
It could be a powerful source of clean energy, but it also poses significant risks if it falls into the wrong hands.
Absolutely. And that's why it's so important to have robust safety protocols, international cooperation, and ongoing research into safer and more sustainable energy technologies.
Speaking of research, our sources introduced us to Glenn Seaborg.
Oh, yeah.
A pioneering chemist who created plutonium.
Wow.
And expanded the periodic table with 9 more man-made elements.
He was truly a giant in the field of nuclear chemistry.
Yeah, his contributions to science are immeasurable.
Absolutely. He revolutionized our understanding of the elements and opened up entirely new avenues of research.
Yeah.
His discoveries have had a profound impact on everything from medicine and energy production to our understanding of the universe itself.
It's amazing to think that we can, create new elements, pushing the boundaries of the periodic table beyond what nature has provided.
It's incredible.
Our sources took us to the cyclotron at Lawrence Livermore National Laboratory.
Oh, wow.
Where scientists are literally smashing atoms together at incredible speeds to create super heavy elements.
The cyclotron is an incredible feat of engineering.
Yeah.
It accelerates particles to nearly the speed of light.
Wow.
And then smashes them into target atoms. Sometimes these collisions result in the creation of brand new elements.
Wow.
Elements that have never existed before on Earth.
I can't even wrap my head around that. Creating new elements, it's like alchemy, but real?
It is.
And these super heavy elements exist for only fractions of a second before they decay into other elements.
Right. It's a glimpse into the most extreme edges of the periodic table.
It's cutting-edge science, pushing the limits of our understanding of matter and the forces that govern the universe.
It is.
And it's not just about creating new elements for the sake of it.
Right.
By studying these super heavy elements, scientists hope to gain a deeper understanding of the fundamental nature of matter.
Yeah.
Which could lead to breakthroughs in fields like energy production, medicine, and materials science.
Absolutely. It's all connected.
It's incredible to think that the periodic table, this iconic chart we all learned in school, is still evolving, still expanding with new discoveries. It makes you wonder what other secrets are waiting to be uncovered in the vast world of elements.
The periodic table is a testament to the ingenuity and persistence of scientists.
Yeah.
It's a roadmap to the building blocks of our universe. And there's still so much more to explore.
Wow. We've journeyed from the heart of a star.
I know, right?
To the depths of a gold mine, from the microscopic world of atoms to the global impact of rare earth elements. Been quite a ride.
It's incredible to think that we've only just scratched the surface of what there is to know about the elements.
I know, right?
Each one has its own unique story, its own set of properties that make it essential for life, technology, and the very fabric of our universe.
It's like each element is a character in a grand cosmic play.
Yeah.
And we're just starting to understand their roles and relationships.
Exactly. And as we delve deeper into the world of elements, we uncover more about the intricate connections between the cosmos, our planet, and ourselves.
I have to admit, I never thought I'd be so fascinated by something as seemingly simple as the periodic table.
Right.
But after this deep dive, I see it in a whole new light.
The periodic table is anything but simple.
Yeah.
It's a testament to the power of human curiosity and our drive to understand the world around us. It's a roadmap to the building blocks of everything we know and everything we are.
So what does this all mean for our listeners? What's the takeaway from this deep dive into the elements?
I hope it inspires a sense of wonder and appreciation for the incredible complexity and interconnectedness of our world.
Yeah.
The next time you pick up your smartphone, think about the silicon that powers it.
Okay.
The rare earth elements that make its magnets work, the copper that carries its electrical signals.
Or the next time you sprinkle salt on your food.
Yes.
Think about the fiery reaction between sodium and chlorine that created it.
Exactly. The elements are all around us, woven into the fabric of our daily lives.
It's true.
Take a moment to appreciate their stories, their properties, and the amazing ways they shape our world.
And never stop exploring.
Right.
Because there's always more to learn.
Absolutely.
The world of elements is full of surprises.
It is.
And who knows what incredible discoveries are just waiting to be made.
The periodic table is a living document, a testament to our ever-evolving understanding of the universe.
Right.
It's a journey that never truly ends. So keep asking questions, keep seeking answers, and keep marveling at the wonders of the elements that make up everything we know and love.